Hello everyone, this is Dr. Suchitra Srivastava, Professor in the Department of Management in the SAGE Group of Institutions, Bhopal. Today I'll be talking about probability theory, which is covered in the third unit of the course Quantitative Methods. This course is offered in the semester 1 of the MBA program. Now, probability is the likelihood of an event happening. We commonly referred it to as the chances of an event happening. In its numerical terms, we express it as a number between 0 and 1, where 0 expresses no chance of that event happening and 1 representing a sure chance of that particular event taking place. Now, the probability of an event is calculated by dividing the number of favorable outcomes by the total number of expected outcomes. Now, the classical definition of probability of an event A is defined as the number of times event A occurs and the total number of possible outcomes. Let us now understand a very important concept. If we want to calculate the probability of an event not happening, then we use the formula P not A is equal to 1 minus probability of A. It means that the probability of A not occurring is equal to 1 minus the probability of A occurring. This can be written as probability of A complement is equal to 1 minus probability of A, where A complement refers to the complement of A or not A. So it signifies that the event that we are looking for is A complement. That is, we are finding the probability of A not occurring. Let us now understand the different types of events that are used in the study of probability. The first is a sure event. An event that will always happen is known as a sure event. Such an event has a probability of 1. We can say that the rising of the sun has a probability of 1. We know that the sun will rise each day from the east, right? So the sun rising from the east has a probability of 1. Next, we come to the independent events. An event whose outcome is not affected by the previous outcomes is known as an independent event. For example, if we were to toss a coin twice. Now, suppose I'm looking at the event coming off a head in the second toss. Now, if I toss a coin and I get a head in the second toss, now this is independent of whether I got a head or a tail in the first toss of my coin. Hence, the coming of head was independent of any outcome which I got in the first toss of my coin. Next, coming to the dependent events. An event whose outcome is affected by previous outcomes are known as dependent events. Suppose I am talking about a pack of cards. Now, the first event I am talking about is the probability of getting a king in the first draw. Now, the probability of getting a king in the first draw is 4 out of 52 because there are 4 kings in a pack, and when I talk about the favorable outcomes, I am talking about how many times I can get the king. That is, I can have 4 kings, any one of these 4 kings, and out of 52 cards. So the coming of a king has a probability of 4 by 52. Right. Now suppose I take out this king and keep it aside. Now I have a pack which has 51 cards, right? Now I am talking about the probability of getting a king in my second draw. Now this probability is given by 3 upon 51 because now one king has already been taken out and has been kept aside. So I'm left with 3 kings now, and hence the probability now is 3 by 51. Next, I come to complementary events. Two events where the probability of one is 1 only if the probability of the other is 0. Now, what does it mean? It means that suppose I'm talking about tossing of a coin. Now, I could get either a head or a tail. So, I can get a head only if the tail event doesn't occur at all. So, the occurrence of tail becomes 0, or the probability of tail is 0. Only then can the probability of the head be 1. Continuing the discussion on the types of events. Events that cannot happen at the same time are known as mutually exclusive events. For example, on tossing a coin once, we cannot get head and tail both. We will either get a head or a tail. Hence, the coming of a head or a tail are mutually exclusive events. Likewise, compound events are events that represent multiple outcomes from an experiment. So we may be talking about several outcomes in succession. Such are examples of compound events. Simple event, an event that represents a single outcome from a sample space. Suppose we are tossing a dice and we are looking at the event or the probability of the event coming of a 6. Then this is a simple event. Next, coming to the exhaustive events. A set of all possible events from a sample space where one event will always occur are known as exhaustive events. So, on tossing a dice, we have 6 possible outcomes. That is, we may get 1, 2, 3, 4, 5 or 6. And one of these is sure to come. Hence, this space represents the set of exhaustive events. Now coming to the laws of probability. Firstly, let's talk about the addition rule. The probability of one or both events occurring is the sum of probabilities of each event minus the probability of both events occurring together. This is expressed as probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Next, we come to another important rule, that is the multiplication rule. The probability of both events occurring simultaneously is the product of probabilities of each of the individual events. Now, this is represented as probability of A intersection B is equal to probability of A multiplied by probability of B. In other words, it means the probability of simultaneous occurrence of A and B is given by the product of probability of A into probability of B. Next, we come to the conditional rule. It states that the probability of event B occurring given that the event A has occurred is the probability of both events occurring divided by the probability of event A occurring. We will be discussing problems based on these laws in a later lecture. Thank you, students, for your patient listening and wishing you happy learning.